Okay, good day. This is Math 130, Introduction to Statistics. I'm Professor McCulley. This is lesson number 5, more graphs and displays. So let's just get to it. Today we are going to graph and interpret quantitative data sets using stem and leaf plots and dot plots. And then we're going to graph and interpret paired data sets using scatter plots. So let's talk about those. Let's get them defined first. So first, a stem and leaf plot is an example of an exploratory data analysis, EDA, in which each number is separated into a stem, i.e. the leftmost digit, and a leaf, i.e. the rightmost digit. There should be as many leaves as entries for the leftmost digit. So that's a fairly straightforward and a fairly easy plot to do. And let's do a quick example of that. So plot the following data as a stem and leaf plot. So here's what we're going to do. We're going to divide this up into a table like this. And we'll call this the stem and this the leaf. So I look through my data here and I see values. I see the leftmost value. I've got a 5, a 6, a 7, an 8, and a 9, and that's it. So I'm going to go 5, 6, 7, 8, and 9. And now we're going to go through the data and we're going to put leaves for each of these stems. And so the leaves are the rightmost data set. So for 80, I'm going to put it, I need a 0 there. I'll put the 0 there. For 67, I'm going to put a 7 here. For 81, I'm going to put a 1 right here. For 73, I'm going to put a 3 right there. For 53, I'm going to put a 3 there. For 90, I'm going to put a 0 there. For 83, I'm going to put a 3 there. For 91, I'm going to put a 9 there. For 65, I'm going to put a 5 there. For 78, I'm going to put an 8 there. For 80, I'm going to put another 0 there. For 71, I'm going to put a 1 there. And for 62, I'm going to put a 2 right there. And so we're just trying to use this graph as a way to kind of see how the data is spread out or where the data is most clustered. All right, let's move on. So the next one, a dot plot, is a method of plotting data along a horizontal number line where each instance of data is represented vertically by a vertically stacked dot. It can be used to visualize how data are distributed and identify unusual entries. So let's do an example. The following data represent high temperatures in Newark for a 21-day period in Newark. Create a dot plot display for the data. So here's how we're going to do that. First thing we're going to do is we're going to make a number line here, and we're going to get a kind of get an idea for the range. So I'm looking through here. 70 looks like the low number. Let's see, 81, 82, 83. Looks like 83 is the highest number. Where, let's see. No, there's an 85. All right. So we'll start at 70 and we'll go from there. All right. So let's get my pen tool. We'll go 70 right there. We'll go 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, and 85. So we're just going to make dots and stack them above the numbers that we have. So 78, we'll put a dot right there. 79, we'll put a dot right there. 74, we'll put a dot right there. 81, we'll put a dot right there. 85, we'll put a dot right there. 82, we'll put a dot right there. 70, we'll put a dot right there. 76, we'll have a dot right there. 79, well, 79's already got a dot, so we're going to stack a value vertically above that one for every time we have a repeated. And so 78, there's our first repeated for 78. 82 has a repeated value. 81 has a repeated value. Cross that out. 79, repeated value. 83, that's its first one. 82, another repeated value. 78, another repeated value. 83, repeated. 79 has its fourth dot. 81, value there, and 80, value right there. And so, and again, when we look at the definition, it says we can use this to visualize how data are distributed and identify unusual entries. And so it looks like most of the data are clustered between 76 and 83, and that this 70 might be kind of an odd day for, or an outlier, an odd number, especially when we're talking about a 28-day period in June. So there you go. Moving on. Paired data sets, two data sets where one data in a first set is matched to one data in a second set, and we can organize that in a scatter plot, a plot where paired data are plotted as points on a coordinate plane. So when I think about a data sets where two data, start over, a paired data set where one data in the first set is matched with a second data in a second set, those things sound like X and Y values that we could plot on a scatter plot. So 10 students take a pre-test at the start of the semester of statistics. Then after the semester, students took a post-test. Their pre-post-test scores are given. Use your graphing calculator to create a scatter plot of the data. So scatter plots are pretty easy. We've done, you can do X and Y if you want. And so here's what we're going to do. We're going to do this a little bit more interestingly using our graphing calculator. And this we're going to call our X value, and this we're going to call our Y value. And so I have a list of values, and so you might want to stop here at this point and get your graphing calculator out. I'll pause for a second. You can hit pause, I suppose, and stop the video, and then we'll move on. So we want to create a scatter plot using the TI 83 and 84. This is the way to do it, using that. And so whenever you're entering data into your graphing calculator, the first thing you always want to do is clear out your lists, because you don't know what the idiot using your calculator before you put in it. And so you clear out your list by hitting stat, clear list, and then we're going to clear list 1 and list 2, and so second L1, comma, second L2. And so let's see what that looks like. So here's my graphing calculator, and this is a big screen, and then this is just the keypad, so everybody can see it. And so when we're doing statistics stuff, we're going to see going to use this stat and the list quite a bit, and the vars and the distribution quite a bit. And so the first thing we want to do is we want to enter data. So we're going to hit the stat button. And the first thing we want to do is clear the list. So clear list is number 4. So we're going to hit 4. And then we have to tell it what lists to use. Now, if you look down on the numbers, 1, 2, 3, 4, 5, and 6, if you look at the value, you have a blue value here that says L1, L2, L3, L4, L5, and L6. Now the graphing calculator has 6 lists that you can put data in, although we'll usually just use 2 lists. So to enter that L1, we're going to hit second, and then we're going to hit L1. And then the comma button is right above the 7 value. So we're going to hit a comma there, and I'm going to go second, and then we're going to hit L2. And so this says clear the lists of the data that is in L1 and L2. We're going to hit enter. It's going to do done. Then the next thing we're going to do is we're going to enter our data. We're going to hit stat, and then we're going to go over to edit. And so we hit that stat button again, and then 1 is edit. And so you can see there are 6 lists. And so this is going to be a little bit different. We have our data given to us horizontally, but we're going to list it vertically. So we're going to enter our data along in L1, and so our X list is going to be L1 and our Y list is going to be L2. So just want to be real clear on that. All right, so let's do that. Hit down there. Now I've got a list with me of that data, but if you need to, you can go back and forth. And so I'm going to enter, it's going to be 57 was the first piece of data, and then 58, and then 60, and then 63, and then 71, and then 72, and then 76, and then 77, and then 78, and then 87. Now, this data does not have to be entered in order. I just did it that way. And once you've got all the data in, you hit your right arrow key, which is on what I call the D-pad for old school gamers. And it takes you to the top of the second list. Now, it's very, very important that you make sure that your data matches up correctly. So if we've got 57 here, we need that 83 right there to match up, or else we'll have a problem. So going back to our calculator, that list there is 83. We're going to hit enter, and then it was 85 was the second one. 52, this person didn't do a whole lot better. And then 69. And then let's see here. The 71 had a 58. And then there was a 78. And then there was an 87. And then there was a 79. And then there was a 62. And then there was a 67. We'll hit enter. So again, if your data pairs don't match up, we're going to have problems with that. So we want to make sure. So always check your data and make sure that you have that all the values in there. So just a random one, 76, and look at that. I'm glad I caught that one. I'm glad I checked them. I might have to check them all now. 87 should be there. Hit enter. And the good news is that this D-pad treats this kind of like a spreadsheet, and so you can just use that D-pad to bop around and change things. So I want to check 57, 58, 60, 63, 71, 72, 76, 77, 78, 87, 83, 85, 52, 69, 58, 78, 87, 79, 62, and 67. Okay. All right, so what we need to do next here, let's take a look. All right, so we're going to open our window and to fit the data. So the way we're going to open our window to fit the data is we're going to hit this window button here. And here we have our Xmin, Xmax. Now clearly our data goes, our X values go from 57 to 87. And so we want to set up a window that gets that, but we don't want to be right on the edge. So I would suggest that we not use 57 as an X value or 87. We want to have a little bit of room on either side. So what you do set it for, or what you do set it to, is certainly up to you. You can make a discussion about, or make an argument about what you choose, but we certainly don't want our min and max to be exactly values that are our minimum values and our X maximum values and the X values. So I'm going to say we're going to go with 50 here, and then I think I'm going to go, what was the highest one? 87. We'll go 95. And then this next one right here is X scale. And so I'm going to put a 5 in there. So it's going to give me a tick mark every 5 units. And then for my Ys, my lowest Y value looks like a 58. And then my highest Y value was an 85. So I'm going to go, again, we'll go to 50. And then if my highest value was an 85, I think we may go by up to 90 here. And again, we'll go by 5s. All right, so I've set my window. What's the next thing say? We're going to turn on our stat plot. So we're going to go second and then Y equals to turn on a stat plot. And so I go second and then Y equals. And so we got a stat plot here. And I want to do the first stat plot. So I'm going to hit 1. And so we've got some some things going on here. And this is we're turning on stuff for the calculator to actually do our plot for us. So the first thing, its default setting is set to off, and so you want to make sure that since it's flashing on, we're going to hit enter there. That'll turn it to on. And then our type, here is our scatter plot. So the scatter plot is the first one. This one here is a line graph, which will just take the scatter plot and connect the dots. This is a frequency distribution, and it will change a lot of the stuff going on. This is a box and whisker plot, and I think this is a cumulative distribution, but I'm not 100% sure. We entered our X values in L1. We've entered our Y values in L2, so we don't have to change anything. That's the default setting. And then we're going to make a mark of squares for every piece of data. And since all of that is now set, I can hit graph, and there is our data. And that looks pretty random. So can't say a whole lot about this data. We just kind of made it. I just kind of made up some data sets, and we've got some random data there. Nothing that I can really make any conclusions about, but that's how we're going to do it. Now, I do want to caution you before I end here that if you go back to your y equals, you will see that the stat plot is on. And I want to show something because this is a common error. If I put a regular equation, we'll put a linear equation, 3x plus 1, and then I go zoom 6. Oh, it didn't cause me any error. Sometimes you'll get an error, and it'll say dimension error. If that problem does occur, go to your y equals again, and if you have plot 1 turned on, you can actually just turn it on off without doing any of the extra work. Just go up to there, hit enter, that'll turn it off, and then you don't have to worry about that stat plot again, even if I were to change the window to fit the data. All right, so the last thing I want to talk about a little bit about is some bad graphs. Bad graphs is a graph that is poorly labeled or purposely misleading. So let's look at, I did a screen capture from the internet here, and I retrieved this from Statistic How To, Data Central, Bush Tax Cuts. So this is not my picture. I pulled it from the internet, giving credit. But outside of my personal bias against Fox News, why is this a poorly constructed graph? Well, if you look at it here at the bottom, this is not 0. This is 34. And so this particular graph makes it look like after January 1st, 2013, that your top tax rate was going to pretty much quadruple, even though it really only went from 35% to 39.6%. This graph is purposely misleading. A more unbiased graph might look something a little bit more like this, and clearly we can see that if I match this as 35% and this is 39.6%, there is clearly a lot less difference shown between these two percentage tax rates, and that's not degrees. I see that now. We should put percent there. That's clearly different than what we saw on this previous graph. So bad graphs, y'all, whenever you're looking at your graphs, please look at them with a critical eye and see if there's any implicit bias in them. And so other poor graphs, pictographs that distort area or volume. Pictographs, I don't care for pictographs anywhere. Circle graphs can also be misleading for the same reason. Graphs with axes that are poorly labeled, and again, we have one that's poorly labeled right here. And then cluttered graphs can distract the reader, so we want to make sure that our graphs are as clear as possible. Well, that's all I got for this lesson today, folks. So, the Marvel fun fact of the day. In preparing for Guardians of the Galaxy, Chris Pratt and Zoe Saldana used protective padding so that they could actually hit each other, but on the actual day of filming, Pratt forgot to wear his protective gear and was kicked so hard that he had a bruise on his ribs for the remainder of filming. Well, again, that's all I got today, folks. Have a good day. Bye.